In, in example 12, the velocity of a particle is given by dx dt equals 4x minus 1 meters per second, where x is the displacement. Initially, the displacement is 3 meters. Now, in part A, we want to find the equation for displacement in exact form. So exact form, just no approximations. So here, we're told in the question that dx dt equals 4x minus 1, and I want now to find the original equation for displacement. So there's no variable t, so I can't integrate this, but what I'm going to do is to find dt dx. I know that will be just 1 over 4x minus 1. Now I've got dx and I've got a variable x. So now I can perform an integration. So t, when I perform that integration, t will equal the integral of 1 over 4x dx. If I make the top the derivative of the denominator by multiplying by 4, just put a quarter out the front. So when I integrate that, I will get a quarter, the log, the absolute value of 4x minus 1 plus c. Now, I don't know what c is, but I'm told in the question when t equals 0, that's the initial displacement, is 3 meters. So when t equals 0, x equals 3. So when I substitute that into my equation, I get 0 equals a quarter log 4 times 3 minus 1 plus c, which is equal to 0 equals a quarter log, natural log of 11 plus c, and therefore c equals minus 1 quarter log 11. Now I'm going to put that c back into my equation up here, where t equals a quarter log, the absolute value 4x minus 1 minus a quarter log 11, which I've got here. Now, I now want to change the subject because I want displacement. So I want the to make x the subject. So what I'm going to do first is just take a quarter out the front as a common factor. I then have used my log laws. I've got subtraction, and using my log laws from subtraction to division, I've got 1 quarter the log of 4x minus 1 over 11, the absolute value. Multiply both sides by 4 to get this expression here. And therefore, using my log definition, I can say that e to the power of 4t equals 4x minus 1 over 11. Now, just multiply both sides by 11 to get this expression down here. I've just added 1 to both sides and taken 4x over to the other side. So I'm swapped the sides, and therefore I can divide both sides by 4 to get x equals 11e to the 4t plus 1 all over 4. And that is what I was trying to do to find the displacement formula. Now, part B is fairly straightforward. We just want to find the exact displacement after 5 seconds. So when t equals 5, I just substitute that into this equation. And just going through the steps here, I get 11e to the power of 20 plus 1 all over 4, and therefore the displacement after 5 seconds is that expression in meters. Part C, we want to find the displacement. In part C, we want to find the time when displacement is 10 meters, correct to 2 decimal places. And again, we just substitute that value into the equation. Here is our displacement formula. In this question, the displacement is 10, so x equals 10, and then we just solve that for t. Now to do that, multiply both sides by 4 to get this expression. I've just subtracted 1 from both sides to get this here, and then divided by 11, so I've got e to the power of 4t equals 39 over 11. I've taken the natural log of both sides to get 4t equals the natural log of 39 over 11, and therefore on the next line I've divided both sides by 4, and that is an approximation. When I put that into my calculator, I get an approximation of 0.32 to 2 decimal places. And therefore, the displacement is 10 meters after 0.32 seconds.